Hello, everyone. Good morning and welcome to Techceleration's 11th edition of Meetup Let's Talk Tech series. Today, Naresh Balaji will be first taking us through AWS Microservices, and the second talk will be Blockchain Use Cases in Mobility by Shashank. We'd like to make this event interactive, hence we've planned the Q&A session after each talk. You can type in your questions or use raise hand option to ask your questions, which will be addressed during the Q&A. I'm super excited to hear from both the presenters. Over to you, Naresh. The stage is yours.
Hey, I'm sure, Anita. Thank you very much for the introduction. Can you please confirm whether I'm audible and my video feed is visible?
Yes, Naresh. Yeah, visible.
Okay, perfect. Hey, thanks everyone for joining and welcome to Toyota Connected India's Techceleration Meetup series. So thrilled to meet everyone. So without any further delays, let me start my presentation. So team, can you confirm whether you can able to see my screen, Anita or Rakesh?
It's still the poster, Naresh.
Okay, got it. Yeah. Okay.
Yeah, now it's visible.
Perfect. Yeah. So, team, I'll be presenting on a topic called as AWS cross-account microservices communication, and my colleague Shashank will take over after my presentation. So let's get started. So here is a small agenda on the presentation that we'll be giving over. So first, I'll brief the team on the microservices communication architecture. So the general producer and consumer architecture that we currently use. And I'll explain the commonly used methods and challenges that we have in making two microservices communicate in private method using private IPs and private domain names. And I'll propose an architecture which I believe that would remove additional overhead of network integrations at layer 2 or layer 3 of the OSI layer for microservices communication, followed by an hands-on demo. So I'll be setting up two microservices and I'll be trying to set up communication between these two in private mode. And finally, we'll have a Q&A. So let's jump in. Okay, so as we all know, microservices architecture of microservices communication has been the buzzword, right, for like past couple of years. In any enterprise organization who involves in product development or application development. So depending upon the team size, we would end up with, say, 5 to 10 microservices, or if it's a really huge team, we'll even end up with 50 to 60 microservices, right? In that setup, so ideally there'll be only one microservice that will be facing the internet, that is facing the public traffic from the customers. Other services would internally communicate among themselves. So it can be either through REST protocol or it can be even through gRPC protocol, right? So these are private. So this need not exceed the AWS cloud or even any other cloud that we deploy into. So those are strictly private communication. Right? I've just quoted an example here. So you see, if we are working with distributed teams and we have a range of teams like backend team, machine learning team, and analytics team. So everyone would have their own workloads, right? So they would have their own AWS infrastructure. They would deploy their applications into that. And not just that. So those teams needs to share data across each other, right? For the application to collectively work. So that is the need that I'll be stressing upon here. And when the scale of that application expands, say that the scope of the project expands, or if the team expands in size to different locations, it has a direct impact on the cloud infrastructure, right? So we as cloud or DevOps engineers needs to set up infrastructure so that these can communicate securely as well as privately, right? So I'll just walk the team through the commonly used methods and its challenges to follow. So the first approach, of course, is the basic approach that everyone knows. Deploy every microservice or every application within the same cluster. Of course, we'll not be deep diving into this approach because of the fact that simply it's not scalable. The second approach is spreading those microservices across different clusters and different AWS accounts. So if you take the example that I've given here, the common multi-account scenario. So there are two types of use cases, right? Either within an organization, you have different teams across different geographical locations. Each has their own AWS accounts, each has their own teams to develop applications. So say that within the organization, we have an application development team and machine learning team. So their accounts needs to get connected so that two microservices sitting at layer 7 of the OSI layer can communicate. Or another valid use case is integrating with a third-party provider. Right? So we'll take an example here. So say that we are integrating with a third-party provider to do product analytics on our application, right? So in that case, what we'll be usually doing is, so we'll be streaming our application logs, our clickstream logs to those providers, and they'll be deriving useful metrics out of it, right? So we have the third-party providers, we have our own application, and let's take the scenario where we need to set up communication in between these two. So in that scenario, if you come over to this diagram, so we'll act as the producer application, right? So we'll be producing the logs, and the consumer will be okay. So we'll be producing the logs as the consumer producer application, and the consumers would be getting those data or logs and will be processing them, right? So in order to set up communication between these two accounts, which are separated from each other, we'll be using VPC Peering or transit KPI, right? So for people who have worked on AWS, so they would know what it takes to set up VPC Peering or transit KPI, right? So in general terms, it is like connecting two different networks at network layer, layer 2 to be expect. We'll be setting up the route tables, right? So we have a VPC here and we have a VPC here. If in case of VPC peering, it's the simple most approach. So we'll be just connecting two accounts directly. So VPC peering and transit can be equivalent to what we call as IPsec tunnels in on-prem data centers, right? So there is an overhead of setting up all these infrastructure at layer 2, right? So even transit gateway is even more complex for people who have worked on transit. They know that it's a really painstaking process to set up the network communication between two VPCs if it's involving transit gateway. So this is a common approach in distributed teams, right? So each team would have their own accounts, own applications, and setting up of communication between them. I'll just walk you through the challenges involved in this. Yeah, so here is the challenges. So as I told, deploying everything under the same cluster would not work for the simple reason it's simply not scalable. When microservices grow in size, so does the node count, or so does the cluster infra, and it's not manageable. And multiple teams deploying into a same cluster. It's a cloud, from a cloud management perspective, it's a nightmare, right? If one cluster goes down, so does all the applications. So everything goes down. It's a single point of failure. So the second approach is what we are interested in. So when we deploy into different AWS accounts, as I told, we'll be using or we'll be leveraging VPC peering or transit. But these two network connections happen, as I told, happen at layer 2 or layer 3 of OSI. So which brings in own additional overhead, right? So we need to set up route tables between these two VPCs so that the routes can be advertised so that it can toggle or it can jump to the other VPC. And we have the additional overhead of subnet ACLs as well. In AWS context, subnet ACLs or subnet access control list. It simply acts as a firewall rules for the subnets. It can be either private or public subnet. So we need to set up all these things. And there's a main drawback in this approach as well. So when we talk about a single VPC, we would not have just one application hosted on it, right? So we would have a lot of applications, out of which we would selectively expose only two or one microservice to the third party or to the other team. But in this case, if you set up route tables, automatically the routes for the other application would also get advertised, right? So without any managerial review or a peer review. So if the developers just set up route tables to make the traffic flow into the other VPC, nothing can stop, right? Because the configuration is made at the route table end, the subnet ACL end. So we are unnecessarily exposing the subnet route tables and the other applications which is hosted on our VPC to the third-party vendor, which is simply not ideal. So these are the different challenges that we may face when we connect to VPCs through transit gateway or VPC peering. So don't get me wrong. So transit gateway or VPC peering is really important, but there is a use case for everything, right? If our intention is just to make two microservices to communicate with each other, transit gateway takes a lot of effort just for making that purpose. So this is just a collection of screenshots, which in order to take the transit gateway to get connected from both the sides, right? So if you're going to connect through transit, so first we'll be creating a transit gateway. We'll be attaching the transit gateway to our VPC. And once the transit gateway is integrated, we'll be using something called as Amazon Resource Access Manager, Amazon AWS RAM. And that transit gateway needs to get shared to the consumer account, in that case, our third-party vendor. So the transit needs to get shared into their destination AWS account. They need to accept the share. That's another criteria. And once they have shared the transit gateway, then comes setting up of transit route tables. So transit route table is the center middleware route table for accepting traffic from both ends. So once you configure the transit route table, then comes configuration of the route tables at the subnet end. So we configured the route table of transit, then comes the VPC route table, which also needs to be configured. And finally comes the subnet ACL. So we'll be ending up doing all these things just for two microservices to communicate. So there should be a better approach for this, right? So thankfully there is, which I'll be showing you with an integration to Elastic Kubernetes service. So I'll show the architecture for it, right? So we have our producer account, as I showed in the earlier diagram. So we have our workloads deployed into an Amazon EKS cluster, which is a managed Kubernetes service from AWS. In that Amazon cluster, so we have our workloads. Say we have our applications which is exposed via REST protocol, for example, and that is exposed via an Istio ingress. So I'll not be deep diving into Kubernetes ingress gateways here. There is a number of ingress gateways for Kubernetes in the market. Istio is one such example. There are other standard examples like Nginx ingress gateway. So ingress gateway, what it does is it simply acts as a gateway for the inside services to get exposed to the internet or to the intranet. So that is basically the use case of an ingress gateway in Kubernetes. So that ingress gateway internally deploys what is called as a network load balancer. So this is a key here. In AWS, we'll be leveraging a VPC endpoint service. So I'll be explaining what is a VPC endpoint service in the demo. So VPC endpoint service, just to be put in a single line. So it can be connected to other VPC endpoints in different AWS accounts, say a third-party account or a consumer account in our use case. So the VPC endpoint can get connected to the endpoint service through approvals and other mechanism. And that is basically it. So no configuration of route tables or subnet ACLs for that case. So the key for VPC endpoint service is a network load balancer. So people who are working with classic load balancer or application load balancer in AWS, so network load balancer sits at layer 4 of OSI. So it is capable of handling both HTTP traffic or TCP UDP traffic. So it's perfectly fine if you use network load balancer for our layer 7 applications. So the network load balancer would get attached to the VPC endpoint service, which would in turn get attached to those VPC endpoints in our third-party or consumer account. And that is basically it. So the consumer applications sitting in this Kubernetes cluster can talk to this Kubernetes cluster in the producer account seamlessly in private method. So that is what I'll be showing the team in the demo. So this is a very high-level architecture. So yeah, so VPC endpoint. What is basically a VPC endpoint is? So AWS has an in-house technology called as VPC private links. So what it basically does is, if you have internal services that needs to be advertised or that needs to get consumed by other AWS entities, in other AWS entities, I mean like other AWS accounts. So we can create something called as an endpoint interface, which in the backend deploys an ENI, Elastic Network Interface. So we'll be deploying this ENI in the consumer account, connecting it to the load balancer here. So this ENI would act as a router basically. So what if you're reaching, say that this is our consumer instance, if it's hitting this endpoint, so AWS configure this ENI so that it sets it up as a router, so that if the traffic is intended for this DNS name or IP address, it would simply pass the traffic across these two AWS accounts in a private way, leveraging AWS private link technology. So that is an overview of VPC endpoint. It works with only a network load balancer. It doesn't work with classic load balancer or an application load balancer. So that is the reason why in the previous architecture, I just put network load balancer here. So that is an overview of VPC endpoint. And then Istio. So I told that we'll be using Istio for Kubernetes ingress gateway, right? So what we'll do is we'll be deploying something called as an Istio ingress gateway that would get attached to the network load balancer. So all the traffic coming in hits the network load balancer, comes to the ingress gateway, and it decides to which Kubernetes service or to which Kubernetes pod the traffic is going to. That is an overall like a definition for Istio ingress. So I'll not be deep diving into ingress, but if the folks are interested to learn more about Istio, I'll be sharing links to learning this in this tech, which I'll be sharing with the team. So advantages, I'll come to the advantages of this approach after my demo. Okay, so it's demo time. So if folks are interested in looking at the source code of all the Kubernetes configurations and Istio configuration, so the source code in this repo, I'll share this link as well. So first, let's go to the demo. I'll do a walkthrough. So I have an AWS account here. I've labeled it as the producer account, and I have another AWS account logged in from a different browser. This acts as the consumer account. First, let me show you the Kubernetes configuration. Okay. So I've logged in into my cluster. Let me show you the Kubernetes service and pods I have. So I have a very sample Python application. So it just gives out a mock response. So let me, so this runs on Python. Yeah. So let me show you the configuration for it. So this is the deployment for Kubernetes, the mock sample application. So I'm pulling in a mock application from my own Docker Hub, exposing it in a container port of 8081. And then a Kubernetes service abstracts the deployment. So it's exposing the service on port 80. And then we have the Istio resources. So before that, I'll show you how the Istio is actually deployed, right? By default, this is very important. So by default, when you install Istio, so it would not deploy a network load balancer. It would by default deploy a classic load balancer. If you want to change that, so if you're going to use Helm charts or installing Istio in your Kubernetes cluster, so we need to override a couple of values there. These two to be specific. So we need to override the annotations of the Istio ingress gateway. So we need to set the load balancer type to true, internal to true, because we're not dealing with any public traffic here. It's all private across two AWS accounts. So it's internal traffic. We're setting it to true. And this is the key here. We're setting the load balancer type to NLB. NLB stands for network load balancer. We override these two settings. And then if you're interested in knowing how Istio is getting installed, so these are the commands. First, we install the Istio base, and we install the ingress gateway. And if you see here, I'm overriding the values using my file here, NLB override. So where I have my annotations overridden. So once you install these commands on your target Kubernetes cluster, Istio would be up and running. So if you want to see the Istio gateway, So I've deployed Istio in something called in a namespace called as Istio system. So you can see here, Istio gateway is deployed and it's using a network a load balancer. So let me show you the type of the load balancer in my producer account. So let me go to load balancers here. Let me change the region. So I have a load balancer here. You can see the type as network and the scheme is internal. So Istio has rightly deployed my load balancer as a network type and an internal scheme. So things are all set in the producer account. So first, let me go to the consumer account. I'll connect to one of the instances in the consumer account. We'll assume that this instance is one of the Kubernetes nodes, right? So let me connect to one instance here. Okay, so we are in the instance. Let's try to curl the endpoint that I'll be using. Okay, so it says I could not resolve the host, so which means connection is not yet established. Cool then. So we'll proceed to set up the connection. So I'm back in the producer account. So I'm under VPC service. We have something called as endpoint service here. Let's create the endpoint. We'll give it a name. So here we have two types. So we do, as I told, we would not have any classic load balancer or application load balancers here. So gateway load balancer is for monitoring the egress traffic from the VPC. It's kind of a firewall gateway. We'll not be looking at that in this demo. We'll select the network load balancer. It would automatically populate the load balancer that we have. So this is important. So I've enabled the acceptance criteria here. So this enables the manager or the peer reviewers to explicitly accept if a request is coming in from a third-party account or from a consumer, right? So we are given the acceptance required here. We'll create it. Okay. So the endpoint service is created, which is pointing to our network load balancer. So we see something called as allow principles here. So we need to explicitly allow. So we need to get the account IDs from our third-party vendors or from our cross teams. Like if you're going to connect this account with the backend team or the machine learning team, for that example. So we need to get the account ID from them. Come here and add a principal. I have that already. So this is the account that I'll be integrating with. So this is the consumer account ID. So I'm in the producer account. So allowed the consumer account to give request to my producer account. Okay. So now let's go back to our consumer account. Come to VPC service. We see something called as an endpoint here, not endpoint service. Endpoint service is for the producer. Endpoints is for the consumer. We'll create an endpoint. Give it a name. So since this is not a managed service by AWS, this is our custom service. Click on other endpoint services. Go back to producer account. Copy the service name. Copy it. Come back and put it here. And hit on verify service. So it says the service name is verified. So the reason why it's verified is we've already allowed the principal here. If you haven't done this step, so it would complain that the service does not exist. Okay. So we given the service name. Let's select my VPC. I have a custom VPC deployed already. I'll connect only private subnets here. So remember, so we're just dealing with private traffic, so no public subnets or no public interfaces. So I'm selecting two subnets for high availability. So in the backend, as I told, when you create this endpoint, it will just deploy two ENIs in these two availability zones. I'll be showing that soon. Let me select the security group. Security group is the way through which you control access to this endpoint in your consumer account. So I'll be showing the inbound I have here as well. Let me select my pre-existing security group and create an endpoint. Okay, so the endpoint is created, but you see something called as the status is called as pending acceptance. So you would have seen that I've already allowed the principal in the producer account, right? But still it says pending acceptance. So let's go back to the producer account. And if you toggle to endpoint connection here, you see here it's pending acceptance. The state is in pending acceptance. So we have two-step process, approval process here. First is approving the account ID. Once the account ID is accepted and the consumer account gives out the request, we need to come back again to the producer account, accept the endpoint. So let me accept it. Okay. So it will take a while. It will take like 2 to 3 minutes for the endpoint to get accepted. Let's go back to the consumer account. Let's refresh the page. It shows us pending here. Okay. So meanwhile, let me show you the ENIs that is it's deploying. Let's go to EC2. Let's check out the network interfaces. So here you can see here, right? I have two network interfaces here. So if you remember, I deployed the endpoint into availability zones, right? So it deploys an ENI, a network elastic interface card, in these two availability zones for high availability, so that even if one AZ goes down, you can still manage the traffic from another AZ. So that is why in the backend, the endpoint deploys two network elastic interfaces. So you can select as much as AZ that the region has. So Mumbai, for Mumbai, just have two. I have selected two regions to deploy the ENI. So this is the traffic bearing network interfaces card. So when you're hitting this endpoint, the traffic is flowing through these ENI, resolving the DNS, and then it's going over to the producer account. So that is what is happening in the backend. Okay. So let's come back to endpoints. Okay. So it's in available state now. So now let's try hitting it. Okay. Okay. Before that, I need the DNS name here. So in the consumer account, if you want to start accessing the services, so you have three DNS names here. One is the common DNS name, and next are the DNS names specific to my availability zone. You can see here, right? It ends with AP South 1B and AP South 1A and one generic DNS name. So let me copy this. Let's do an NS lookup first. So it's getting resolved. Now let's hit the endpoint. Okay, so we're getting response. So this response is coming in from my microservice and my producer account. I'll show you that. So I have my sample application here, right? So this is the application that was deployed into my producer. So you can see here, it's just sending in a mock response. So you're just getting that in here. So it's all done. We have set up endpoint service in the producer account, set up an endpoint in the consumer account, connected these two using approvals, and then we try to hit it and we're getting a response. So as you can see here, there's no peering connections. There's no transit gateways as well. There's no transit gateway VPC or anything, but still the instance has managed to reach a cross account microservice deployed in another AWS account. So, but there is a catch here. If you see here, let me go back to VPC endpoints. You can see here these VPC domain names. I'm sorry, the endpoint domain names are pretty tedious, right? So it's difficult to manage, or it's difficult to embed all these domain names into our application code. Because at a future date, these you may redeploy the endpoint service and this would automatically get swapped, right? So there is a way for it. the way for it to manage the domain name. So the endpoint service and endpoint natively supports Route 53 private hosted zones. So let me go back to my producer account. Let me go to Route 53. I have a hosted zone. So this is a private hosted zone, not a public one. So I have a public hosted zone, and I have associated the VPCs from the two different accounts. One is the producer account, another one is the consumer account. So the reason why I associated two VPCs here is so that the domain request from both the VPCs can resolve against each other. And if you want to know how to associate it, I have the commands. Let me show you that. So this cannot be, the associating cross-account VPCs is not possible through AWS console, unfortunately. So these are the CLI commands. I'll share these commands as well. So if you want to associate two different VPCs across accounts, first you need to extend the invitation from the producer account and then log in into the consumer account through CLI, associate the request. So I've done that already, and that I've associated the VPCs. Now I have this record, right? Let me edit this record to the latest endpoint from my consumer account. Let me copy this, put it over here, save this. Okay, so our custom domain name is ready. So let me copy this, go back to my consumer account. First, let's do an NS lookup on this. Okay, it's getting resolved. So when you hit api.resources.cloud, it's resolving to my VPC endpoint. Cool then. So let me first then hit the endpoint. Okay, sorry. Okay, so we're getting response. So earlier we hit it using the tedious endpoint service domain name, which was not easy to manage, especially if you're embedding that into your application source code. But our custom domains are easy to manage. If I do a verbose on this. Yeah, so you can see here, it's coming in, the traffic is coming in from the NY proxy, which is the sidecar proxy for the STO. So you can see here, the traffic is reaching STO from the network load balancer, and we're getting the response. So this is how you configure the endpoint with a private hosted zone in Route 53 and have custom zones, domain name zones for easy management of your backend URLs. So yeah, so that is all I had for the team for the demo. Let's go back to the advantages that I showed. So first advantage is pretty obvious, right? So I have not done any sort of network level connections here. So all I did was just connect a network load balancer at layer 7 of the OSI model, and only that load balancer can be accessed. So you can see here, if you have other applications in the VPC, those cannot be accessed unless it is sharing the same load balancer. So that is the key there. And another one, as I told earlier, so the tedious process of connecting two networks via a VPC peering or transit can be avoided. Even the route tables can be avoided if it's just two microservices communication. And as I've seen earlier, so explicit account ID whitelisting is required so that two accounts simply cannot be connected automatically. So we can have an automation in place. So by the way, all the manual steps I did are compatible with Terraform or CloudFormation or any automation tool that is in the market. So we can wrap around all the process, including a manager overview or a peer overview, so that the request from the consumer can be approved. And at last, as I showed, it supports the Route 53 private hosted zone by associating both the VPCs. So just associating the producer VPC would not suffice here. You need to associate both the VPCs so that the domain names can get resolved. So these are the main advantages that I see from this approach. And yes, that is pretty much it. So I'll pause here for any Q&A from the team. If team has any sort of questions on even the setup, or if you want me to brief on any of the components that I deployed, if you want a basic definition of those as well, please don't hesitate to ask that. Okay, so if there are no more questions, thank you, team. It's been a pleasure to host this topic to you all. I'll hand it over to Shashank now, who will be taking over. Thanks, team, for the opportunity.
Yeah, thank you, Naresh. Thank you for the wonderful presentation. So before I begin, Anita, can you please confirm if I'm audible and my video feed is visible?
Yes, Shashank, audible and visible.
Okay, cool. Thank you. Thank you for the confirmation. Let me present my screen first. All right. Is it visible now?
Yeah. Yes, Shashank, it's up.
Okay, thank you. So before I begin, thank you for running the presentation today. So the topic that I'll be presenting today would be blockchain and how it can be used in mobility as a platform, right? So there are various use cases. So I'll be touching upon a few common use cases and try to give you a brief overview about blockchain. So considering all the different levels of expertise over here, I'll just be covering the ground level of blockchain, but I'll be happy to take up any questions on questions about any advanced topics as well. So the agenda for today would be, so I'll start with the introduction to blockchain. So I'll be explaining what is blockchain, what is it all about, and there's a common misconception, right? Whenever anyone hears the word blockchain, they automatically associate it to the Bitcoin, but that is not the case. So I'll try to, differentiate what a blockchain is, what a Bitcoin is, and all about, and then touch upon how it works, how the technology itself works. It's not a nascent technology as such, but then there are few people who are experts on the subject, right? It's still being implemented. So in terms of implementation, it's still very relatively new, but in terms of theoretical knowledge, it was introduced way back in the 90s. So I'll be touching upon how it works and then going briefly over the features of blockchain, how it can be benefited us to society as a whole, and then the types of blockchains which are available currently in the market, and the various crisscross combinations that one can set up a blockchain architecture in. And then we'll be going over a few already developed applications and then few theoretical ones as well that has a potential to be implemented in the future. And then a very small set of limitations of blockchain as well. So I'll be covering all those up in my first section of introduction to blockchain. Then I'll start with the common use case. So we'll be exploring one use case after another. So I'll be touching upon 3 different use cases now, which are predominantly more common in the market now, which one of which has already been explored upon. So we'll be touching upon that and then wrap it up by the Q&A session. So yeah, here is the introduction to blockchain. So as you can see, what is a blockchain? So blockchain is basically a chain of records, right? Stored in the form of blocks. It's like how we, in a traditional database, we have the records being inserted. So just like that, it's a chain of records. It's stored in the form of blocks and linked with each other, right? So after it is linked with each other, it forms a blockchain. So what it actually contains is a transactional information, and then new block is added for every new transaction. Basically, every new information, a new block is added, and the information is shared with all the parties in the network, right? And this blockchain, right, is not controlled by any single person. So basically, it is distributed in nature. So if I belong to the network, I have access to the blockchain. I'll be able to view the data inside it. If anyone, any participant in the network can access the blockchain, can see what is inside the blockchain. So the first block in the blockchain, right, is called the Genesis block. So the Genesis block is basically the first block of the blockchain. And each new block is linked with the previous block with the help of hashes. There's something called hashes. So with the help of hashes, each new block of information is linked with the older block. So what is this hash? So basically, hash is cryptographical algorithm, just like your RSA or SHA 256 and all that. So hash is completely dependent on the data that is stored in a blockchain. So with the help of a hash, the data can be uniquely identified inside the blockchain, right? So let's say blockchain is a word, so that is the data that I'm storing inside a block. So I have a very unique hash for this blockchain, and that cannot be deciphered. So even if it is deciphered, it can only turn out to be blockchain and nothing else. So with the help of a hash, we can identify the information inside a block very uniquely. So basically, yeah, like I said, hash is a mathematical code that uniquely identifies the data inside the block. And each of these blocks contains three things. One, the data, the actual data that needs to be stored. Second is the hash. Hash is basically, like I said, the mathematical code that uniquely identifies the data, and also the previous hash. So previous hash basically means the hash of the previous block. So in this case, let's consider the second block here. It will contain its data, its hash, and the hash of the previous block. So with the hash of the previous block, it is able to connect with the previous block to form a chain. So that's how a blockchain is formed, right? So let's see how it works. So each transaction or any new record is recorded as a block in a blockchain, right? As you can see, a block is added in the blockchain, and each block is connected to the one before it with the form of hashes, like I said. And with every new block that is added to the blockchain, the entire chain becomes more robust because it's more secure, and you cannot take out one block and form a connection, overall connection for the blockchain. So it becomes more robust and forms an irreversible chain, basically. So now the question arises, so why is it so difficult, or people say it's impractical to modify a blockchain, right? It's very difficult to alter a blockchain. How do they say that it is very difficult to alter the blockchain? So it's basically because of these hashes and the node participants. So there are two new things. One is the hash that we've already discussed about, and the other one is a node participant. So what happens here, as you can see with the image here, right? So each of these hashes is linked to the previous block. So as in when, let's say, an attacker wants to change a data inside this block, the hash of this block changes. So if the hash of this block is changed, that means the previous hash that is stored inside this block is also changed. So the entire chain is unlinked now. Get the idea, right? So if these hashes are changed, the entire chain is unlinked, and then this entire thing no longer forms the blockchain. So considering this example, it is very difficult to modify the blockchain. Now there are cases, well, these days computers are very, there are supercomputers and computers are more advanced, and then you can change the hashes very quickly. So let's say even if I want to modify this data and then I form a hash, I can quickly go to the next block and then change the previous block hash and somehow link all these together. So the catch here is the node participants. So even that cannot be established because of these node participants. So basically node participants are, maybe you can relate to the miners in Bitcoin. So these are the parties who come and validate every new transaction inside the block. So they validate the transaction in the blockchain. In order for these transactions to be valid, right, they have to store the hash of the previous block. So how they validate these transactions is with the help of various methods, such as proof of work, proof of stake, and all those methods. So one of the most common method that is being used in Bitcoin as well is the proof of work. So what happens here is when a transaction is introduced, the nodes start validating these transactions by solving a complex mathematical problem. So only when the majority of these nodes are able to solve this problem and then agree upon a consensus, right? Agree upon something that this transaction is valid, then and only then that a new block is added to the end of the blockchain, and then a new set of information is added to the blockchain. So that's how the node participants come into picture. There are various methods that they use. One common is, like I said, the proof of work. There is one more thing called the proof of stake, where they have to stake the existing coins or existing assets that they have to validate these transactions. So that's another such method. So basically, in a nutshell, if I have to add a new transaction or a new block in a blockchain, I store these information and then transmit this information to all the networks of the node. And the node participants, they validate these transactions with the help of, let's say, by solving a mathematical problem. And only after the majority of the nodes agree upon the transaction will a new information is added. So that's how the entire blockchain is working. Now, coming to the features of the blockchain, right? Like I said, it is decentralized. That means no single person, holds the authority of the network. While everyone has a copy of the ledger, but no one basically can modify it or own it. And it is modeled upon a peer-to-peer network, so which basically means there's interaction only between two parties, which eliminates the interaction between a middleman or a third party. So which saves time as well any monetary thing which is involved by the involvement of the third party. Then there's this immutability of the blockchain, which basically means the data once written into the blockchain cannot be changed or altered under any circumstances. Then there's this consensus where the majority of the people have to agree on the transaction. Only if they agree on the transaction that a new information is added. If it is not agreed upon, the new transaction is actually deemed invalid. So these are the features of the blockchain. So what benefits do these features and the blockchain brings into the picture, right? So first thing, it brings trust, because I can rest assured that I'm receiving the right information, the information that at least the majority of the people have agreed upon. Then, and in any circumstances, my confidential information will only be shared with the participants and no one else. And then the security of the data, right? All the transactions here is immutable. So basically, once you add a transaction, it cannot be changed or altered. So I know my data is secure there, and no one can delete a transaction as well. And it also brings in efficiency, right? So with the blockchain being shared among the members of the network, there's this time-wasting reconciliations where we have to give the transaction to every node, every participant in the node is avoided, is basically eliminated. So these time-wasting reconciliations are also eliminated. And to speed these transactions, we can also have a set of rules, probably develop a smart contract embedded on the blockchain, and then it can be executed automatically. So it also brings in a much more robust and efficient architecture into picture. So what are the types of blockchains available in the market currently? So one most common type of blockchain is a public blockchain, which all of us are familiar with. That's what Bitcoin is operating on. So basically what happens in a public blockchain is anyone can join the network and participate. So a transaction is visible to anyone in the network, and then they can also add their own information in the network. And it allows anyone in the network to verify the block. So I can also be a node participant. You can also be a node participant. We can verify the block and then add a new block. So that's how the public blockchain works. And then there's a private blockchain where it is actually shared among only trusted participants. Usually what happens is there'll be one single organization that will form the blockchain among its trusted participants, and then these transactions are not visible to everyone in the internet. Right? The organization can control who it is, who are allowed to participate, who is it visible to, who are allowed to execute some protocols and then maintain these shared ledgers. Then the third type of blockchains are the permissioned blockchain. So usually any organization which establishes a private blockchain, they'll have these permission blockchains only. So like I said, it'll give you permissions for people to execute a transaction, give permissions to see the transactions. So this basically places restrictions on who is allowed to participate, right? And then the participants need to obtain specific invitations. These days, people are familiar with apps like Discord, where you are allowed to participate on invite-only basis. So just like that, the permission blockchain gives you invitation and permission to join the blockchain. So that's what the permission blockchain is all about. Then there's a consortium blockchain. So basically, a group of organizations sit together, decide on the responsibilities of maintaining the blockchain, and then start the blockchain. So the organizations determine who can access the data and who can add information to the data and who can verify the data. So these organizations decide on that. They have a shared responsibility for the blockchain. So it is usually ideal for businesses where all the participants need to be permissioned and have a shared responsibility of these blockchains. So these are the types of blockchains currently available in the market, and there are various use cases where people use these set up a blockchain architecture using one or both. So basically, they can have a private blockchain and a permission blockchain combined together in their use case to form one specific blockchain. So these can be used interchangeably and together as well. Then the various applications of blockchain that is currently available in the market. So like we all know, one is for the digital currency, the most common Ethereum, Bitcoin, and all the cryptocurrencies, where it can be used for lending, paying, repaying, e-commerce, and all that. Then there's health keeping as well, where patient's PHI information, like the protected health informations, are all stored inside a blockchain. So imagine a case where you visit one doctor, and let's say a year after that you visit another doctor, and the second doctor knows all the information, all the kinds of medications that you've already undertook with the help of this blockchain, right? So they have the idea of who is the doctor who have treated you before, what kind of medications or what kind of prior ailments that you previously had, because all these are stored inside a blockchain, and then it is visible to the doctors. So another such thing is the record keeping, where you store the PHI informations, like I said, and then the voting as well, where you vote on a blockchain which is already implemented in different smaller countries, but not on a large scale democratic countries like India, China, and other countries. But yeah, on a smaller scale, yes, this is already established. And then the IP rights as well, right? I have an IP right, and then I put it on a blockchain, and it is irreversible, right? So I know who it is being transferred to and on what basis. No one can infringe on that right, and all that. And then there's this equity market, debt market, and corporate debentures, where it can be used to store information and then move the assets from one party to another. And then there's this smart contracts, basically which has spawned to NFTs for that matter. So what the smart contracts basically do is you write a set of instructions, and then as and when you store information, these instructions are automatically executed on those information, and then a result is deciphered upon. So that's what the help of smart contracts, with the help of smart contracts, blockchain achieves, right? Then there are also limitations of blockchain. It's not a fairy tale altogether. Currently, a few of the common limitations are the lack of awareness. Like I said, blockchain technology itself was introduced to the world back in the 90s, right? But then people relatively started to know about it only in the 2009, 2010, after the one application was introduced, that is Bitcoin. So only after that was introduced, people started to know what a blockchain is, how it can be used. They started identifying the various applications that the blockchain can bring upon the world. Right, one is lack of awareness. Then another thing is the limited availability of technical talent who can architect a system like blockchain. So like I said, right, while I was explaining the types of blockchains available, there are different methods of blockchain that can be used interchangeably and together. So in order to develop a well-defined system, an architect has to be skillful enough to decide how the organization shapes up to be in the future. So it should be scalable to an extent to where there is no problem that can arise out of the architecture, right? So there are very limited technical people associated with blockchain who currently work on developing architectures based on blockchain. Then comes the immutability in nature. Yes, agreed. Even though you store an information in blockchain and it cannot be altered and it stays throughout. But there are cases where you have to go rectify these information. This becomes permanent, right? But there are cases where you go back and say rewrite that information because you see something wrong in that, which is not the case in this type of in the blockchain, because once a record is inserted into a blockchain or once a block is inserted into a blockchain, it becomes irreversible. You cannot change it or alter it in under any circumstances. So the immutability here is a double-edged sword. Basically, it has its pros as well as its cons. And then the key management. So this is also another key limitation of blockchain, basically, right? So when you say key management, since blockchain uses cryptography, so it uses various public and private keys for that matter. So when a user has to transact information, he has to also transact the receiver's public key and all that. So key management, managing these keys, maintaining these keys and storing it for a longer time becomes a problem, right? So you would have heard in the earlier days of Bitcoin, there are a lot of people who would have stacked many Bitcoin, millions of Bitcoins for that matter, and then forgot where it is, forgot the keys to access it. So if you lose your keys, you lose access to the information, you lose access to the blocks, you lose access to your your coins, your cryptocurrencies for that matter. So key management is also one serious problem here, where you need to have the keys available with you all the time. Then comes the scalability. Blockchains are not scalable as their counterpart centralized systems, right? Since it is built on the consensus mechanism, right, and every node has to verify the transaction. So this limits the number of transactions that a blockchain can process at a time, since it involves all the nodes. As and when the blockchain keeps on getting bigger and bigger and more participants are included here, so the process of transaction slows down gradually. So just to give you an example, Visa transactions for today can process up to 1,500 transactions per second, whereas the Bitcoin transactions can only process around 7 Bitcoin transactions per second. So look at the difference here, 7 to 1,500. So the traditional systems are faster when you scale it to such higher levels when compared to blockchain. But there are different ways wherein you can avoid it. That is by probably using a private blockchain where there are only limited number of participants who will validate your transactions and all that. So with the help of utilizing other blockchains along with the public blockchain, we can actually overcome the scalability. And then the consensus mechanism, right? Like I said, majority of the people has to agree on a transaction, has to agree that the transaction is valid, and only then a block is added to the blockchain. As and when you see that the blockchain is scaled to such a larger extent that there are a huge number of people involved, the number of people who have to agree on the transaction also increases. So, like I said, in order to agree on a transaction, they have to perform a mathematical problem. They have to solve a mathematical problem and then agree on the consensus. So there are huge computational costs involved and energy is involved. So there are a lot of bases in China. There are a lot of people who have set up bases in China to solve these mathematical problems because the energy is relatively cheaper compared to all the other countries, right? So there are various such cases where people have established bases just to solve these mathematical problems and get bitcoins on solving these problems. So these are some of the few limitations of blockchain that we have today. Yeah, and before I proceed with the next section, let me pause here. I know the information is a lot for people who have just started with blockchain, so let that information sink in. And then until then, I'll be happy to take up any questions that you guys have. Feel free to use the chat or probably raise your hands so I can unmute you, and then you can go from there. All right, then I consider no questions so far. So I'll proceed to the next section. That is the various use cases which are currently explored so far for blockchain mobility. So let's start with the first one, that is the supply chain management system. Right. So currently the challenge here is to process payments and to track the movements of raw materials, spare parts, vehicle parts, and even fuel for gas stations, and even the used car sales for that matter. So imagine a situation.
Prashant, sorry to cut you off. You have a question in the chat, Prashant.
Yeah, thank you. I didn't notice that. Okay. Hello, Abhishek. So I see that you have a question, which is I have a basic understanding on blockchain, but if I want to start, where to begin? That's good. So you have to start first to reach somewhere. So I would say, well, the mother of all information currently is Google. So that's how many of us started with. So I would say just starting with on what a blockchain is and implementation would help you on that. I have a few resources handy which I can share probably in our meetup page after this session has ended. So which will give you a brief idea of what a blockchain is, and maybe set up a small blockchain network internally with, let's say, a few peers, 5, not more than 5, so that you understand how it works, so that you can establish rules surrounding blockchain and play around with those rules. And once you familiarize yourself with establishing rules on a blockchain and how it works, right, you can probably open it up to a larger audience. I hope that answers your question. All right, any more questions? Okay, so I'll I'll start with the first use case that I started with, which is the supply chain management system, right? So like I was saying, the challenge currently that we have is to process payments and then to track the movements of raw materials, the spare parts of all these vehicles, and even the movement of fuels from the main location to various different distribution points and then various different gas stations, right? So that's the challenge. So imagine a situation where, let's say your vehicle is broken down and you visit a dealer to get it fixed. Now the dealer suggests you to replace the part, right? That's what most dealers suggest. So they suggest you to replace the part. Imagine the situation. Now, how do you trust the dealer? So how sure are you that the part needs to be replaced and cannot be fixed altogether? How do we know that the part is disposed properly and not, just taken out and fitted in another vehicle, right? Basically reused in another vehicle. And then how do we also determine where our part is coming from? Where if my part is coming directly from the manufacturer, or if it's just taken out from one vehicle and fitted in my vehicle. So and then how do these manufacturers know basically where are all their parts going from the manufacturing plant till the distribution point till the end vendor and fit it to the right vehicle or not? So how do we track all that, right? So these are some of the common challenges which the manufacturing units face. So when we have the supply chain management system implemented through a blockchain, right, you add these transactions. So you have a block, you add these block of information. So basically a block here would mean an information about a spare part, right? For example, so you have the information about the spare part added into a block. You say the spare part is manufactured on so and so date. The first Genesis block is born. Now the block is again sent to a distributor, first party distributor, and then he adds another block to that blockchain, and he says the part arrived at this location on so and so with the timestamp along with the serial number of the part. So the same thing follows till the end distribution, right? Now the entire movement of the asset, basically the entire movement of the vehicle part, can be tracked with the help of the blockchain. So even if your dealer says that the part needs to be replaced, you go and check what is the part on the blockchain, and you'll be able to see where it came from, whether it was fitted in another vehicle, or whether it is a brand new part that he's trying to fit. And even after that, the old spare part that you have, right, if it is properly disposed, it should have an end block in the blockchain, right? The end block might also mean a waste management system or something like that. So it should have an end block. If it has another block associated with another vehicle, that means the spare part that was taken out of your vehicle is actually fitted into another vehicle and reused. So all of these can be tracked with the help of blockchain. Similar case for used car sales, for that matter. Let's say I own a car, I sell it to a vendor, and then you buy it from the vendor. How do you know if you're paying the right price for the car? How do you know what was the price paid by the vendor, right? So if you have all these information in a blockchain, which you can easily see through, you know, what is the information, what is the amount paid by the vendor to the car owner, and then what is the amount that you can pay to him, and if the vehicle itself has undergone any insurance, vehicle itself has undergone any repairs for that matter, can all be seen through the help of blockchain, which makes the overall process smooth, right? So and transparent. So this implementing these challenges with the permission blockchain network with respective organizations like the manufacturing unit, the dealership, and all that, and obviously the final owner of the part or the final owner of the vehicle, which will help develop a transparent system, right? What do these eliminate, and then what do we I mean, what are we benefited with, right? So this will help avoid fraud, like I was discussing about any theft. Basically, you manufacture tens of thousands of parts, and then a few thousands of the parts are eliminated or basically stolen from you, and you don't know where it went. But if you have a blockchain being implemented, you just have to track it with a serial number, right? You know where it went to, you know which dealer fitted to which vehicle, you know to which in which vehicle it is currently residing in. The entire transaction process becomes transparent. We can also use smart contracts to develop this blockchain for various use cases where you know you set of rules to identify what is the right price for it and execute it automatically as and when the information is stored, right? And then, like I was talking about, tracking, where you'll be able to track where each and every part is going, or where the fuel is going from the main station to all the different gas stations and all that. So these are the benefits that can be introduced in the supply chain management system with the help of blockchain, right? That is our first use case that I want to touch upon. The second thing is the usage-based insurance program. So currently, one of the major drawbacks of the insurance system in India is, right, you pay the same amount of premium every year, irrespective of your usage pattern, right? It doesn't matter how you drive. It doesn't matter how you use it. Doesn't matter whether you use your car or not at all, right? You have to pay the same premium every year without even having to use the car. So with the help of usage-based insurance, right, implemented in blockchain, so every car is fitted with controllers, CAN controllers, which can transmit information about the vehicle's usage, and each of these information can go in as a transaction inside the blockchain, and then developing a smart contract based on these information. Every year, assume these information comes in and in the form of a blockchain, and you have a set of rules which anyone can see. That can determine your insurance premium based on your usage. Let's say you drive 10,000 kilometers today for this year, and then also on the usage patterns, you write a smart contract, basically a set of instructions, and then you derive a premium. And let's say another person who would have driven for 50,000 kilometers for this year sees that contract, tries to see how his premium is arrived at, and then can identify that it is a completely transparent system, right? The premium changes based on the usage pattern. The premium changes based on how much the first person has driven, how much the second person has driven. So this is a very smart solutions. So these kinds of things have started being implemented in other countries, but they've never used blockchain for that matter, because if you use a blockchain, the driver is completely aware about how his premium is being calculated, right? He has information about how much his vehicle has driven, where it has met with an accident and all that, and he knows that based on all this information, my premium is calculated. And if I want to backtrack, I can easily go and see the set of instructions and derive the premium amount myself, right? So this is one such smart solution that can be implemented with the help of a blockchain, where drivers could automatically, pay their insurance bills to be, on usage, and insurers could instantly calculate the driver's premium based on the usage pattern. So the benefits that this brings on the table is the smart contracts implementation, which is relatively new here, where you would have heard about NFTs and other things being implemented with help of smart contracts, and also the fair premium pricing based on the usage. So this is another such benefit, another such use case that blockchain brings. Right. Finally, I would want to say that this is not just in theory. There are a lot of implementations already being started on blockchain. There's one such thing called Mobility Open Blockchain Initiative, right? So this is basically a global non-profit entity whose goal is to make transportation or driving more efficient, decentralized and then sustainable, preserving the nature also. So this is another such initiative which has already started with the help of blockchain. So it's no longer a theoretical concept. Blockchain is no longer a theoretical concept, and blockchain is no longer can no longer only belong to cryptocurrency, the Bitcoin or the Ethereum or any such cryptocurrencies. It has a widespread, wide-scale usage, just that it has only recently started being realized, right? So I thought I'll explain about this a bit, but they have a very beautiful intro video about it. So let me play this so that we get an idea on what they're trying to do. Let me know if the video is audible. Is it audible?
Yes, Shashank.
No, Shashank. Can you play?
Oh, that audio is not.
Yeah, I mean, I've just stopped playing just to get the confirmation. Okay, I'll play.
Include audio, you can share.
Able to hear the audio, Shashank.
Populations will increase
Is it
by
audible now?
50% by 2050, making the effects of urbanization, including pollution and traffic congestion, incredibly difficult. In many countries, vehicles tend to be the largest source of carbon emissions. In addition to the environmental impact, 1.25 million people die in traffic accidents per year across the globe. To mitigate the effects of vehicle congestion and overcrowding, cities need to develop new ways to manage road infrastructure and vehicle flow. Here at the Mobility Open Blockchain Initiative, we believe that we can leverage the convergence of rapidly maturing technologies, AI, IoT, and blockchain, to assign anything, a person, a vehicle, or piece of infrastructure with an identity. These digital identities can unlock the potential for a mobility network with intelligent entities that can perform transactions and communicate with each other. This in turn enables cities to build, operate, and finance their infrastructure in new and radically better ways. To enable and accelerate this transformation, MOBI and its members developed the first ever standard for a blockchain-based vehicle identity, VID. The VID can create a digital twin of a physical vehicle, unlocking potential for vehicle-to-infrastructure, V2I, and vehicle-to-everything, V2X payments from a car wallet, and eliminating the need for a payment account associated with a person or business. With a car wallet, a vehicle can pay as it moves on a road, allowing users to pay for infrastructure they utilize. In addition to road use, cities are also able to charge for congestion and carbon emissions. To offset these costs, users can sell services and data. Users can sell extra seats in their vehicles. Users can charge others to use their vehicles when not in use. Vehicles can also report flaws in infrastructure, accidents, and more in real time. Using the VID car wallets and tokens, users can also receive credit for using green or clean fuel, choosing public transit, or taking an alternative route. These charges and credits can be used to manage road network demand within the city, giving city managers, transit agencies, and infrastructure operators new tools to solve the biggest and least tractable urban mobility problems. The vehicle wallet could also act as a digital tracker and communicator for the vehicle. Having vehicle identities on a network allows vehicles to communicate speed, location, direction of travel, braking, and even intention. Coordinated mobility, taking advantage of trusted identities, swarm intelligence, and distributed positioning will permit vehicles to operate more safely and much faster in a given area. MOBI's VID, together with vehicle wallets and tokens, will permit infrastructure owners to charge users fees to pay for repair, maintenance, and new construction.
Yeah, that was it. That was the video. So yeah, like I was saying, right, the blockchain is no longer in theory now. There are various concepts that are being looked on and then are trying to be implemented, right? So the wheel of the blockchain has already started moving, and the question is, where do we want to be, right? Whether in the back seat or take the driving seat in this revolution. So that's the ultimate question that we are supposed to ask, right? Well, that's all for today, and I'll be happy to take up any questions that you have. Thank you. Feel free to use the chat or probably raise your hands. So like I said, I'll unmute you so that you can ask your questions directly. All right, I think that's all there is. Thank you guys for being okay. Yes, Ramya.
Ramya, we've enabled the mic. You can.
Okay. Sorry, I was talking on the mute. So this is a quite good information, and like I have just started learning. Can you please share the PPT also with us?
Yeah, sure. The PPT is going. Both the PPTs, for that matter, will go on the meetup page. Right, Anita?
So Ramya, we will upload the recording of this video in our YouTube channel, and I will share the link in the meetup page as well.
Okay, thank you. And like in the blockchain, like whenever we read the basic thing, like we are always focusing on the energy consumption, right? Like it is too high when for like one transaction. That's what we always that's what we always listen, right? How is there like a way for this also, like how this energy is going to be, like is it how we are going to address in future? Just it is a basic question.
Right. So what you asked is a good question. When you read about energy being consumed, right, most of them are talking about a public blockchain network utilizing the proof of work. So what happens in a public blockchain network is anyone can act as a node participant and validate a transaction, right? And then since there are more people involved, there are more people trying to validate the transaction, and then all of them trying to use the energy. And like I spoke earlier about, bases being set up in China just to validate these transactions, and then because of the energy output there, or the energy rating there is comparatively cheaper when we compare to other countries, right? So in order to avoid this, trying to set up a public or a permissioned blockchain, trying to set up a private or a permissioned blockchain network can solve this. So that is our first solution, wherein you allow only a set of participants to validate a transaction. You give authority to only few people to validate the transaction. So in that case, only those few people are trying to solve the problem, and then only those people who are trying to solve the problem energy is consumed only for those people, not for the rest, right? What happens in a public blockchain network is anyone can validate the transaction. So all these people are trying to compute, and then the energy is consumed for all the people. So that is one such solution. The other solution is the way in which they try to validate the transaction itself, right? So what I was talking about when I said the proof of work is basically all these nodes have to do some work and validate the transaction. So work is basically solving a mathematical problem. So there is another way wherein you can validate a transaction that is called a proof of stake. So what happens here is only if a node is allowed to stake in something they have. For example, in the cases of Bitcoin, or not in the Bitcoin, sorry, in the case of Ethereum, right? So let's say you have some coins of X coins of Ethereum with you. So only if you're allowed to stake that in the blockchain, only if you're allowed to pledge that in the blockchain, then only you will be given the permission to validate. So not all people are ready to pledge their coins, right? So in that way, the number of people validating the transactions are also reduced. So this saves energy and time as well. I hope I've answered that question.
Yeah, you answered. Thank you, Shashank. Makes sense.
Thank you, Ramya.
Thank you. Thanks for that question, Ramya. Shashank, there's another question from Abhijit. Solving urban mobility problem is issue, but can you further elaborate use of blockchain to solve this? Shashank, you're on mute.
Yeah, thanks, Anita. Thanks, Abhijit, for the question. So when you say urban mobility problem, right? So that's a very vast concept in general. Can you be more specific on what problem that you're trying to touch upon here? Can we unmute Abhijit, Anita?
Sure. I'm just doing that. Abhijit, can you unmute yourself and ask the question?
Hello, am I audible?
Yes, Abhijit.
Yes, Abhijit.
Yeah. Thank you, Shashank. The question was basically like, as the video was mentioning, right? So the use of IoT and then maybe the networking and the data that we generate within different cars. Those data will be used to manage the traffic around the roads in the cities and providing the incentives. But the question was like how exactly the blockchain will help or maybe managing these kind of data for the future traffic management systems. So that was my question.
Right. So one such use case that you can relate to is not in the blockchain for that matter. The Google Maps that we see, right? In a way, it tries to determine the traffic in a particular area using the red markings or the yellow or the green markings. So how do you think that they determine? It is basically the number of people trying to use Google Maps on the road or number of people connected on the road, and then all their information is sent to the satellite and the computation happens there, right? And then based on that, we get the feedback in our cell phones or wherever we try to use the maps and identify the congestion and all that. So in a blockchain, and we are not aware of what information is stored or what information is sent to Google Maps to derive these computations. So what happens here in a blockchain is all these informations are transparent. You know what information is going away from your car, and you know where this information is stored, right? And using the same set of information, you establish some kind of computation to derive at the same thing that Google is already doing without the help of blockchain. And then you can also rest assured that your data is safe, right? There are a lot of privacy concerns when you give your data to one single party, and then there are a lot of questions on how they manage the data, how they use the data and all that. But in this case, since it is transparent, since you know what you're giving out, since you know how they're calculating based on what information they have, this is completely secure.
Okay, right, Shashank. So it's finally it's like a tractability and then the security of what we are sharing between the vehicles, right?
Right.
Yeah, thanks.
If there are no more questions, I think we can wrap it up for today. Anita, over to you. Thank you guys for being such patient and wonderful listeners. And thank you for all those questions as well. And thanks for the opportunity. Thanks. Over to you, Anil.
Yeah. Thank you, Naresh and Shashank. That was a super cool presentation on AWS microservices and the blockchain use cases in mobility. Thanks for putting this together for us. So to the audience, a recorded version of this talk will be available on the Texleration's YouTube channel, and we will update the link in our Meetup page as well. So we'd love to hear from you. Please share your feedback, ratings on the Meetup page. And on behalf of Team Texleration, thank you, audience. Happy weekend, and meet you again in Texlerations next. Thank you so much.